cat's eyes, in fact, two of them, and I'll use these to discuss the relation between the confidence interval and p-values. Here's the cat's eye picture on a 95% confidence interval. The cat's eye tells us the relative plausibility or relative likelihood that these values along here will be the true level of support in the population. So where the cat's eye figure is fat, where this curve is high, we've got relatively high plausibility, high likelihood. And as the cat's eye figure gets progressively thinner, these values get progressively less plausible, less likely as the true values in the population as we move further away from our point estimate. And down here beyond the interval, the cat's eye figure is really quite thin, and so we have values that are really relatively implausible as we move away from 53 and down to 51 or 50, or the same as we move up to values beyond 55 and out towards 56. It's the fatness of the cat's eye that indicates relative plausibility or likelihood of these values along this axis here. Let's look at it slightly differently. Suppose you were testing the null hypothesis that support was 50, here 50%. So what's the p-value? The p-value is the probability that if this null hypothesis is true, we'd get the sort of data, or more extreme, that we actually observed. Now this confidence interval is calculated from the data, so the data will be round about here somewhere, and if this is the null hypothesis that's true, it's pretty unlikely we'll get data like this or even more extreme or in the other direction. So we'd expect a very low p-value for a null hypothesis out here. What about a null hypothesis, say at 52? If that null hypothesis were true, then it's perfectly reasonable to expect we'd get data round about here, relatively close to the null hypothesis, or more extreme. So we'd expect a moderately high p-value round about here. And in fact, this is a mapping of approximate p-values for null hypothesis values at these corresponding places on this axis. So if we were testing the null hypothesis that support was 50, and then this data set would lead us to calculate a p-value of 0.003. If we were testing the null hypothesis of 52, we'd get a much higher p-value. If we happen to be testing a null hypothesis right at one of the limits of the confidence interval, then p-value is 0.05, corresponding to the 95% confidence interval. Now, a small p-value means that we're likely to reject a null hypothesis, that null hypothesis value is implausible. For example, 0.003, highly implausible given this data. Put it the other way around, if our confidence interval tells us that, well, a value of 50 is really quite implausible, well beyond the interval, then this corresponds to a small p-value, and so we would reject this implausible null hypothesis value. To put it slightly differently again, a small p-value, 0.003, is evidence against 50 being a reasonable null hypothesis value. It throws doubt on the null hypothesis, and the smaller the p-value, the stronger the doubt on our null hypothesis. So the signal from a p-value, what a p-value indicates to us, and what the cat's eye and the confidence interval tell us, hang together as we would hope, as we would expect. And this is the basis for understanding how the two relate, and the basis for some guidelines, some rules of thumb that allow us to translate backwards and forwards between confidence intervals and p-values. And here are 4 guidelines or approximate rules. If this is a 95% confidence interval and the null hypothesis is within the interval, in fact about this far back from one of the limits, then approximately p is 0.2. 1/3 of MOE, 1/3 of MOE, back, p is about 0.2. When the null hypothesis value is right at one of the limits, we know that p is 0.05. When the null hypothesis value is beyond the confidence interval, then p is going to be less than 0.05. In fact, if it's about 1/3 of MOE beyond, then it's approximately 0.01. And if it's further away still, in fact about 2/3 of MOE away, then p is 0.001. So remembering these four graphics and these four guidelines allows us to read off from any 95% confidence interval and any null hypothesized value to read off an approximate p-value. Here's a bit of practice. So these are all 95% confidence intervals, and here is our null hypothesis value. Let's eyeball what the p-value is. So here we know the null hypothesis value is beyond the interval, so p is a bit less than 0.05, maybe it's around 0.03, something like that. In fact, it is. Here it's within the interval, so it's greater than 0.05, only a bit, maybe it's 0.1 or 0.2, something like that, 0.12. Here the confidence interval is quite a long way away from the null hypothesis value, so there's very strong evidence against this. The p-value will be very small. In fact, it's beyond 2/3 of MOE away, so if the null hypothesis value is about here, that'd be 0.01, so it's 0.001, and so this is less than that, less than 0.001. Strong evidence. Here we've got p distinctly greater than 0.05, maybe it's 0.3, 0.4, 0.29. Okay, here it's even greater, maybe 0.7, 0.8, 0.7. Now here, eyeball 1/3 of MOE, 1/3 of this distance beyond, that's round about there. So if the null hypothesis value was there, then p would be 0.01. It's a bit further away, so a bit less than 0.01, maybe 0.008, something like that, 0.006. So we're interpolating, but by bearing in mind those four guidelines, we can eyeball a p-value just when we look at a confidence interval and the position of the null hypothesis. Let's do it in the reverse direction. And in fact, this may be the best way, the most insightful and informative way to interpret a p-value. So if we have a point estimate, if we know the mean and we know the p-value, but we haven't been told the confidence interval, we can actually eyeball it. So we know the confidence interval will extend down from our point estimate and up, and it's going to extend down far enough so that the relation of the confidence interval length, or MOE, this length at the lower half of the confidence interval, and the null hypothesis value will give us p 0.006. So it would come down to maybe about there, say. Yes, it does, round about there. Now 0.7, we're going to have the confidence interval extending well past the null hypothesis value, so maybe down to about here. And 0.29 coming down beyond the null hypothesis value, but not all that far, maybe down to about there, or a bit further, there. 0.001, the confidence interval will extend part of the way, but maybe somewhere around about here, we can't tell exactly. Oh yes, okay. 0.12, we know it's going to extend past the null hypothesis value, down to perhaps about here, not all that far past. Oh, there it is. And 0.03, so it's going to extend almost all the way down, maybe to about there, but not quite. Ah, there it is. Now, one of the important lessons of this sort of discussion is that traditionally, If people see 0.006, they think, that is a very strong result. We very clearly know what's going on. But in fact, the confidence interval even here is very long. So, as usual, the confidence interval is very informative because it tells us the extent of uncertainty in our result, whereas the p-value tends to hide that and perhaps mislead us into thinking that we have a very clear-cut result. Now, it's quite true that we have strong evidence that 0 is not the true value, but in fact, any value from 20 up to beyond 120 is a reasonably plausible value. So there's still enormous uncertainty. And even here, when we have less than 0.001, we've still got a confidence interval extending from roughly 20 up to higher than 60. So there's still quite a lot of uncertainty. And we'll only appreciate that if we translate from our p-value into an approximate confidence interval. And if you have a result that has a p-value round about 0.05, then you know that the confidence interval extends from the point estimate down to round about 0, or the null hypothesis value. And that could be quite a big confidence interval. In summary, there are the forward guidelines, worth visualizing and remembering these 4 figures to help us map between a 95% confidence interval and an approximate p-value. And even more valuable, in the reverse direction. When we have just a mean and a p-value, we can eyeball how long the confidence interval is. Here's another way to play around with the relation between a 95% confidence interval and the p-value. I'm at the ESCI page C, I, and P, and I can use this big slider to move our 95% confidence interval here to any position I like in relation to the fixed null hypothesis value. So in this position, I know the p-value is a little greater than 0.05, and the mu-naught value is not as far back as 1/3 of MOE, so I've got a value of maybe round about 0.1, turn on the p-value, 0.11. If I move the confidence interval down to perhaps, let's say about there, I've got a p-value a little less than 0.05, but within the 1/3 of MOE, so it's greater than 0.01, maybe it's about 0.03. Let's have a look at 0.03. I can turn on small hints, and they correspond to our 4 guidelines. So you could start off using them if that would help you use those guidelines, but possibly by now you don't need them, and you can simply move the whole confidence interval, make it a game. Here we've got a p-value of maybe 0.7. Let's have a look. 0.57. You get the idea. Enjoy.